This is before the lamp strikes, so the lamp is gone. Okay, here's C, there's L. And effectively I have here now a pure AC square wave. Okay, now effectively we said we can analyze this thing by saying I've got a sine wave right there. Now again, remember the reason for why we can use the sine wave is essentially because this guy is best represented with the Fourier series, which means it's got a fundamental term, and a third harmonic, and a fifth harmonic, so on and so forth. The only thing that's going to matter is going to be this. In exercise 4, you're going to validate that. The only thing that's going to matter is the fundamental term. Okay? Now, in this circuit, if you remember, the output voltage is going to become infinite if the frequency I drive it at is 1 over root LC. Now, up until now, what we've effectively said is, well, what we can do is we can think of this thing as having some sort of resistances that are going to limit that value. Okay, we looked at this in the last lecture for what would happen if we had an RL and an RC with that L and that C right there. Okay, so we've gone over that a little bit. The question is, what causes RL and RC? Well, for the inductor, winding resistance, and some other things that we'll talk about today. For RC, that's caused by some things about the dielectric. So in any real system you actually make, and you're making a real system in this particular case, all right, what we need to do is actually sit down and think about for ourselves what causes these things, what real components actually behave like. All right, a capacitor in general is not a capacitor. An inductor in general is not an inductor. Same thing for a resistor. Now, a resistor's not as bad. But we've got to talk about those real components, because when you get into real design, real components and how they behave are pretty important. All right. Okay. All right. So let's take a look at sort of today's notes. I basically said, okay, let's talk about the non-idealities of resistors, capacitors, and inductors. So you guys may want to tune out to some of this, but you probably shouldn't. All right, especially because the stuff on the inductors towards the end is really going to matter. So is the capacitor part going to matter quite a bit for your actual design. Okay, so I'll start with the resistors, but that's pretty basic stuff. All right, now some things you guys know. You probably are used to that picture of a resistor. Okay, you've dealt with that lots of times in the lab. And I would hope that most of you guys are actually able to read that resistor. All right, I'll talk about how to read a capacitor here as we go. All right, but that's something we'll get to. All right, if you don't know how to read a resistor, you should probably try to. If you go through that drawer in that lab upstairs, remember, you guys are going to find out that everybody's come along and just treated that thing like crap, and you're going to think you're getting a 1 kilo ohm resistor, and you're going to get a 1 ohm resistor, and it's going to blow up in your face. So just make sure you actually read that stuff. All right, here's 2 types of resistors. Now you can probably get a good sense of this one. It says 10W, 10 watts. Okay, so this thing's rated to carry some power. Now these are the ones that you guys typically use. All right, now this one is not rated to carry that kind of power. All right, so typically on a resistor, there's some key things we got to keep in mind, and they really do affect designs, especially if you need a precision design. All right, so if you're in the aerospace industry or the military, or you're designing something you really need some precision, you really have to be careful about what components you pick. You may think picking a resistor is simple, but it may not be. All right, so this resistor here, when it has, and you can't see that too well, when it has this gold band on it right there, it means it's got 5% tolerance. All right, so 5% tolerance, what's that mean? Well, if this is let's see, if I look at the colors on this one, I think this is a 68K resistor. All right, if it's 68K, and it's got that 5% tolerance, that means it's 68K plus or minus 5%. All right, so it's not going to be exactly 58K. That may not be good if I'm looking at a precision application. If that's the case, I might want something a little bit better. All right, some of the other things, this guy's rated for 1/4 of a watt. All right, which means that it can pass 0.25 watts. Okay. If I need to pass 10 watts, I need something like this. Now, what's the difference? Well, these are made with different materials. Okay. Some other things on here. This thing is got temperature variations to it. Okay, so if the temperature varies from 0 degrees C up to 100 degrees C, this temperature might change. All right, if you're talking about an aerospace application or a military application, that may not be good enough. That may throw off the gain of some circuit, all right, and affect some things. Okay. Now, in general, these resistors as well, these ones here, are meant for 250 volts maximum applied. Okay. If I start to apply voltage to this thing, typically there's a voltage coefficient. So if I apply a lot of voltage, the resistance is going to change. That may be something that matters. And there's all sorts of things that will affect this. Okay. Once I solder this into a circuit, it usually changes its resistance permanently. Okay. Not by a large amount. Okay. By a couple of percent. All right. Also, if I load cycle, if I apply high voltage to it and then turn it off, high voltage to it and turn it off, and that's the kind of thing that might happen, that also will probably permanently change it. Vibrations, high vibrations can change the resistance, humidity, all sorts of different things. Okay? That's something to kind of keep in mind. Now, there's the types of materials. This is what's called a carbon composition resistor. Different materials have different behaviors. Usually when you need precision, you get one of these types right here. This is a 1% resistor. Okay, the blue ones are usually 1%. And it's metal film. This one's carbon film, okay, or carbon composition. This one here is metal film. Metal films are usually quite a bit better in terms of how they behave. Okay, 1%, and then